Hello.
Hello, sir.
Okay, are you getting my voice?
Yes, sir.
Okay. So I think we have completed the image formation by the concave lens. Huh?
Yes, sir.
Can you tell me the last
We
topic?
were doing some Lakers formula.
We have completed. Okay. So today we will discuss the simple and the compound microscope. Simple and the compound microscope. Do you know what is simple microscope?
Yes, sir.
Basically, a simple microscope is just a convex lens. Okay.
Yes, sir.
A
Sir,
simple
just
microscope.
say lagging, sir. Yes,
Okay.
sir. So you can continue, sir.
Actually, Harsh, your voice is lagging.
Voice is lagging.
Your voice is lagging.
Sir, maybe because it's not connection. It's raining here. I don't know. Maybe it's
Okay,
network
okay,
problem.
okay, fine, fine, fine. Okay, okay. So we will discuss the simple microscope one by one. We will discuss, and
Yes, sir.
after that we will discuss the compound microscope. Not very a hard topic. This is very simple topic today.
Yes, sir.
Simple microscope. So simple microscope is basically a convex lens, and when you are placing the object at the within focus of the
Yes,
convex
sir.
lens, then you will get a virtual and magnified image. Then you will get a virtual
Virtual
and
magnified image.
magnified image. So if suppose I am just taking this convex lens, so this is a uh, convex lens, okay, and before that, now we should know some of the things before the simple microscope and before the working of the simple microscope. We
Yes, sir.
should know what is microscope. Basically, what
Okay.
is microscope? Microscope is something an optical instrument. Microscope is an optical instrument, means with the help of which we get a larger image of the object.
Yes,
Is it
sir.
or not?
Yes.
So first we will see what is microscope. So an optical instrument which magnifies a small object. So an optical instrument which magnifies a small object means with the help of the
Yes, sir.
microscope, if you will see the small object, you will get a larger image of that small object. Okay. So now there are certain things that I want to tell you. If for a normal human, for a normal human being, the least distance of distinct vision means the least distance up to which we can see is 25 centimeters, and
Yes,
the
sir.
maximum for the normal human eye, the least distance up to which the normal human eye can see is 25 centimeters, and the maximum distance up to which the human eye can see is infinity.
Yes, sir.
If you will try to see an object which is at a less distance than 25 centimeters, then there will be the strain in your eyes. Suppose uh, this is the eye, and from your eye, uh, so the distance 25 centimeter up to here, this distance is
Yes, sir.
25 centimeter, and this distance is also known as the near point of the eye. Near point. And means up to what maximum distance the eye can see is infinity. This distance is infinity, and this is known as the far point of the eye. Far point of eye. Now, in the study of the optical instrument like microscope, telescope, we should know what is visual angle. Visual angle.
Yes, sir.
So basically, the visual angle is the angle formed by the object or the image at eye. Okay. For example, this is the eye. This is the eye. Okay. And this is some object. This is some object, and this object is subtending some angle at the eye. Suppose this angle is theta.
Yes,
So
sir.
this theta will be the visual angle. Okay, so angle formed by object at eye. Angle formed by object at eye. This is the visual angle. Okay, so one more thing here, na. In case of the visual angle, if the height of the object will increase, okay, then the visual angle will also increase. You can see here. If I am increasing the height, then you can say that this angle theta will increase, na.
Yes, sir.
So you can say the visual angle, or you can say height of the object is directly proportional to the visual angle. So height of object is directly proportional to visual angle. To visual angle. Okay,
Yes,
now
sir.
there is one very important term that we will use again and again: magnification of microscope. Magnification of micro.
Microscope.
Yeah. Magnification of microscope. So remember, magnification of microscope
Yes,
is
sir.
the ratio of visual angle formed by final image final image divided by the visual angle formed by the object kept at D.
Yes, sir.
Visual angle formed by the object kept at D. Now what is D? D is equal to the 25 centimeter distance.
Yes, sir.
This the near point, okay? This distance from the eye. This distance is 25 centimeter. So this is known as D, capital D. Okay, so now please first note down, then we will discuss this simple microscope because these are the basic things that will be required.
Yes, sir. So yes, hold on.
Completed, Harsh?
So just try.
Okay. Write down.
Done, sir.
Okay. So now remember this what is this magnification of the microscope? Visual angle formed by the final image, visual angle formed by the object kept at D. Okay, this I am explaining. Now you should
Yes,
know
sir.
what is visual angle. Means the angle subtended by the object or the image at I is known as the visual
Visual
angle.
angle.
Okay, now I am explaining this visual angle formed by the object kept at D. The meaning of this visual angle formed by object kept at D means D equal to 25 centimeter. So if you are placing the object at a distance of D and this is the object, okay, this is the object and this is the eye here, and at I this object is sustaining an angle of suppose alpha. So this alpha is known as the visual angle formed by the object kept at D. So this is your object and this object is placed at a distance of D from your eye. Okay, so visual angle formed by the final image, basically this is represented by beta and this is represented by alpha. Okay, so this I will use directly now see this triangle. Can you see this triangle? In this triangle, suppose if height of the object is height ho is the height of the object.
Yes, sir.
This is the right angle triangle. This is a right angle triangle. And this angle is alpha. This will be the base of the triangle. This will be the perpendicular of the triangle. So from here we can find tan alpha. So tan alpha will be HO divided by D.
Yes, sir.
Tan alpha. And if alpha becomes very small, if alpha will be very small, then I told you many times tan alpha can be written as approximately equal to alpha. Okay, so instead of tan alpha, you can put alpha, that will be equal to HO divided by D. So alpha will be HO divided by D. Now we will discuss the simple microscope. Simple microscope. Okay, if you will understand simple microscope properly, na, then compound microscope, to understand the compound microscope is easy. Okay,
Yes,
simple
sir.
microscope.
So this is the last topic, right?
This is the last topic.
Okay. Yes.
Simple microscope. Basic things is here, na, to
Yes.
calculate the magnification. Means the most important thing is here in the microscope, telescope. There is a confusion to the student in calculating the magnification. Okay.
Yes, sir.
So now we will take one lens because microscope is basically simple microscope is basically a simple convex lens. So this is a lens, convex lens, and this is the principal axis, and an object is placed here. This is the object placed. Okay, this is the object placed.
Yes, sir.
Hmm. So in our syllabus, I told you we have very thin lenses. Now we will draw the image for this object. So as this
Yes, sir.
object is placed, so first ray from this object is parallel to the principal axis, and if a ray of light is parallel to the principal axis, it will pass from the focus. It will pass
Yes,
from the
sir.
focus of the lens. Okay.
Yes, sir.
Now another ray. Now what should be the another ray from the object to form the image? It should pass from the optical center like this. Okay. Because for the image formation, two rays should be there. Now these rays are converging or diverging?
These are diverging.
Diverging. So these rays will never meet. So we will produce these rays in the backward direction.
Yes, sir.
Then we will get the image there. So I am just producing this diverging rays in the backward direction, and we will see where we will get the image. So I think somewhere here we will get the image, and this will be from the dotted line, okay? Because
Yes, sir.
these are just, we are producing these rays only, and the image will be this much bigger. This will be the image. Now what is the use of the microscope? An optical instrument which magnifies a object. Magnifies the
Yes.
object means produces the large image of the object. Now you can see here, this was the object, this is the image. Now this is the large image now of the object. So means this is a microscope. This is basically, this is a simple microscope.
Yes, sir.
Okay. So now we will do some calculation. Suppose this image has the height hi, and object has the height ho, and this object is placed at a distance of ue, at a distance of ue from the optical center.
Yes, sir.
Optical center. Okay. Okay. One more thing here now will be used, that will be visual angles. Will be visual angles. So I told you, if you want to calculate the magnification for the microscope, the magnification for the microscope will be beta by alpha. What is beta? Beta is the visual angle formed by the final image, means this angle. This angle will
Yes,
be
sir.
beta. Harsh, your voice is lagging actually.
Sir, the net is not good today, sir.
Okay. Okay, no problem.
Sir,
Fine.
it's been raining since 1 week, so I don't know. Maybe because
From
because
1 week,
the
from 1 week it is raining.
yeah, it hasn't stopped.
Okay.
So just sir, because inside my house the net is fine, like it's working.
Oh.
Just a minute, I'll check. Is it fine now?
Now it's fine. So magnification was beta by alpha. What is beta? Visual angle. Visual angle formed by the image divided by the visual angle when the object is placed at a distance of d. This thing should be clear. Magnification is beta by alpha now. Harsh, are you getting my voice?
Yes, sir.
Okay.
It's lacking, but it's fine.
Okay. So m is equal to beta by alpha. Okay. M is equal to beta by alpha. So now alpha we can find very easily. This concept. We will use this concept.
Yes.
So this will be the visual angle found by the object. Visual angle found by the object kept at D. Okay, so this will be 10 alpha. You can find alpha from here. But beta, how you will find beta? So see this triangle, this, and this triangle. So in this triangle, we can find 10 beta.
Yes, sir.
Now 10, can you tell me what will be 10 beta in this triangle? This triangle, this.
Tan beta. It
Hmm.
will be
Mm-hmm. It will be 10 is perpendicular of a triangle divided by base of triangle. Ten is perpendicular of a triangle divided by base of triangle. Harsh, your voice is not coming to me.
perpendicular.
It will be h naught by ue. H naught by ue. Okay. It will be h naught by ue. And I told you this beta is very small. This beta angle is a small angle. So you can write 10 beta. So you can write 10 beta to beta. Okay. So instead of beta, you can write, instead of 10 beta, you can write beta, and that will be h naught by ue. So beta you can write h naught by ue.
Hello, sir.
Harsh, are you listening now properly?
Sir, I got disconnected.
Okay.
Just a minute, sir. There's some
Okay, okay,
problem.
okay. It's fine, it's fine. No problem.
Okay, sir. I think now it's fine.
Now it's fine. Your voice is okay now.
Sir, if it's happening like every minute to me,
Okay,
like I can't hear you and I don't think you can hear me.
okay. So what should we do now?
So you can continue, sir. We'll see, sir. If something
Otherwise,
happens again.
then then how will you understand this concept?
Yeah, okay.
So
Sir, you can continue. We'll see.
can we conduct this class tomorrow? Otherwise, now if I will explain you, no problem. I can take the class also because, uh, but
So you
if
can take a
hmm?
class tomorrow. You're free?
Yes, means I am free if actually not today your internet is not working and if I will teach you this microscope and after that I will teach you the compound microscope, then there will be a problem now if
Sir, you can continue. If there is one more like
okay,
problem here, then we'll do it
okay, okay,
tomorrow.
okay, okay. So first understand this 10 beta. I have calculated this 10 beta from this triangle. From this triangle, I calculated the 10 beta. So 10 beta will be h naught by ue. Okay,
Yes, sir.
perpendicular divided by base. And I told you we are taking this beta is a small angle. So if this beta is small, then we can write 10 beta approximately equal to beta.
Yes,
Okay,
sir.
many times we have done this thing. So instead of 10 beta, we can put beta. So it will this equation will become beta is equal to s naught by ue. Now we have alpha. We have alpha now, and
Yes,
we
sir.
have beta now. We have beta now. So we have alpha beta. With the help of alpha beta, we can find
Yes,
the
sir.
magnification beta by alpha. So magnification is equal to beta by alpha. So beta is h naught divided by ue, and this is divided by h naught divided by d. Okay, this h naught and h naught will be cancelled out.
Yes,
So the
sir.
magnification of the simple microscope will be come out to be d by ue. D by ue. This will be the magnification of simple microscope. Okay, so you can know. So basically, this is just simple microscope. It's very simple. That is why it is known as simple microscope.
Yes, sir. So just a minute, write this.
Okay, okay, write down, please.
So scroll down. So guys, scroll down. So beside the formula, can you write what's D and UA?
What?
Beside the formula, can you write what's D and UV?
D
D is the
divided by
distance and UE and
no. D is the distance. You are right. But what
yeah.
distance? D is these 25 centimeter distance. Okay.
Yeah.
I have written here also. You can see.
Yes, sir.
And what is UE, na? UE is the distance where the object is placed. Okay. You can see this is
Okay.
UE. U suffix E. This
Yes,
is
sir.
U suffix E. Okay.
Yes, sir.
Done?
Yes, sir.
Okay. So this is the case of the simple microscope. Now in simple microscope there are two cases. First case is in which we will calculate the maximum magnification. In which we will calculate the maximum magnification. Okay. So for the maximum magnification, the image should formed at D. Case number 1. Remember the formula of the magnification of simple microscope, D divided by UE. And what is UE?
Yes, sir.
UE is the object distance and D is the 25 centimeter. Okay. Now case number 1 for the magnification. Case number 1, maximum magnification. Maximum magnification. So one point you have to remember for the maximum magnification, final image, you can see here, final image is forming somewhere here from the lens. In case of the maximum magnification, the final image should formed at D, capital D. Final image should form at D. Okay.
Capital
So final,
D.
capital D. Final image is forming at capital D. Now here, sign convention will play a very important role. Now see again in figure. Now final image in case of the maximum magnification is forming at D distance. Okay. Suppose this is the distance D. So here the image is forming, suppose. So you will take this distance positive or negative.
Yes, sir.
This is the biggest challenge for me to explain. Okay, if I'm asking what will be the sign of UE you will take, positive or negative?
Sign of UE, negative.
Negative. Very good. Because UE you will measure in the opposite direction of the incident light. So
Yes,
many
sir.
times I told you, now I think you have understand. So object distance, you will take UE and that will be negative UE. And final image is forming at D, and that D you will take as minus D, because this D will be
Yes, sir.
also on the left hand side. Now F is the focal length.
Yes, sir.
F is the focal length of the convex lens. F is the focal length. As my headphones battery is low, actually I have to change my headphone. Okay, just wait a minute.
Yes, sir. Yes, sir. Just
Hello, Harsh. Getting voice? Hello, Harsh.
sir, can you hear me?
I can hear you. Can you hear me?
Yes, sir.
Okay, now it's fine. Okay, so what we were discussing? We were discussing this. So now there is a lens formula. Do you know what is lens formula?
Yes, sir.
What is that?
1 by F
1
is
by
equal to 1 by V plus 1 by
1 by V minus 1 by U is equal to 1 by F.
1 by F. Yeah.
1 by V minus 1 by U. These are the actually basic formulas. At any cost you have to learn. Okay.
Yes, sir.
Because at each and every step these formulas will be used. Like this formula, lens maker formula. Like if I'm asking, suppose what are the laws of refraction, what is
Yes.
Snell's law? So at least these things you should clearly understood. What are these? So we will apply this 1 upon V minus 1 upon U is equal to 1 upon F. Okay, so now 1 upon V we have minus D minus 1 upon
Yes,
U
sir.
we have U is equal to minus UE we have minus UE we have, that is equal to 1 upon F. Okay, now we can solve it. It will be minus 1 by D and this will be plus 1 upon UE. This is plus because this is minus and this is minus, and minus multiply, it will become plus. That is equal to 1 by F. Now we want to find the value of 1 upon UE. And why?
Yes,
I
sir.
will tell you why I am finding the value of 1 upon UE. Okay. So 1 upon UE from here will be 1 upon F plus 1 upon D. This will be the value of 1 upon UE. Now, what was the magnification for the microscope? D divided by UE. D divided by UE. Now, here we have 1 upon UE, na?
Yes, sir.
Okay, so we can put the value of 1 upon UE this. So we can put the value, that is D multiplied by 1 upon F plus 1 upon D. Now we will multiply D with whole bracket. So we will have D by F plus we will multiply this D with 1 by D. It will become D by D, that is 1. So we will have 1 plus D by F. So magnification we
Yes, sir.
will 1 plus D divided by F. So this magnification will be there. This will be the maximum magnification you will get. This will be the maximum magnification you will get. Now there is another case for the relaxed eye. When the eyes are relaxed, what will be the when the eyes are in the relaxed condition? What
Yes,
will
sir.
be the value of magnification? That is the case number 2.
Magnification will be 0, right?
No. Magnification can never be 0. The reason is
it will be less.
it can be negative, it can be positive, but it can never be negative, because magnification can be 1 or it can be less than 1.
Yeah.
It cannot be 0, because how can the magnification will be 0? If you are taking the point size image, then
Like not 0, but the magnification will be less because if the eyes are relaxed and the
you are right. Magnification as compared to this magnification, the magnification will be less, obviously.
Yes,
Obviously that is means you are right. Case number 2. For normal adjustment, or you can say relaxed eye, left eye. Okay, in this case now you have to remember, in case when our eyes are relaxed, okay, so we see the objects very means in an easy way. So final image in this case should be formed at infinity. Okay, final image, this is the condition, final image
yes, sir.
should be formed at
Infinity.
at infinity. Okay, now the value of the V will become infinity, means the position of the image will be infinity, and U will be same, U will be minus UE.
Yes, sir.
Okay, now you can apply this formula, 1 upon V minus 1 upon U is equal to 1 upon F. So from here you can calculate the value of 1 upon UE. So 1 upon V is 1 upon infinity minus of 1 upon minus UE. This is equal to 1 upon F. Now 1 upon infinity, remember this is equal to 0. Okay,
Yes,
1 divided by infinity is 0.
0.
So this term will become 0 and this term become 1 upon UE. So the value of 1 upon UE this time, you will get 1 upon F. Now what was the magnification for the simple microscope? D by F, D by UE. So now you can see, instead of 1 by UE, instead of UE you can put F.
Yes, sir.
So the magnification in this case is equal to D by F.
dy.
So now I will show you this magnification is less than the previous magnification. Earlier the magnification was 1 plus this.
1 plus d by f. Yeah.
Now this is only D by F.
Now only is d. Yeah, so it's less.
That is why this is less.
Okay. Yes. Sir,
Yeah.
can you keep an extra class tomorrow?
Yes, we can.
Yes, sir. So you can keep. So same time.
Timing, I will tell you.
Okay.
Actually, tomorrow I have to check some of the question papers, means the answer.
Sir, if you take for 1 hour also, it's fine. Like we'll come at least
Okay.
near to completing the portion.
Okay. Fine.
Like myself, I have done till I'm in dual nature right now.
So you are in your school, you are
Not in my school. Like I'm doing it myself.
you yourself
Yeah.
dual nature.
Yeah. In school at least they have done the portion there, like saying.
Okay. Dual nature and matter radiation is started from the photoelectric effect, no?
Yeah. Planck's constant and all those things. Hertz experiment. This time the boards are too early.
Yeah, of course.
Like the last time I was going to give boards was in 10th. They kept it in April, March, May. It was in May, I guess. The boards.
Okay.
That got cancelled.
Okay.
So how's the health, sir, now? How's your health?
Actually, right now, I am just recovering. I mean, I cannot say my health is just like previous health. Means
Okay.
actually, I was suffering from actually fever last 10 days.
10 days.
But I was taking the classes continuously. But at the last time when I felt that I cannot tolerate, so then I go to the hospital.
Yeah.
And then now my health is improving right now, but it is improving.
Yeah. Okay. In the process.
Yeah, in a process means it will take at least 1 or 2 days and I will be all right.
Yes,
Right
sir.
now also I am all right, means I'm not saying I'm just sick, but there is something left now in the body, the virus.
Yeah.
So
Second, you scroll down.
some effect of the virus is still left.
Okay.
So that have to be overcome all. Then actually I have made a plan to complete the syllabus. Actually I will make a plan tomorrow also.
Okay.
How we can finish on time means actually I have to make some slides and all that. Okay, so I am having a plan and hopefully that plan will work out.
Okay.
But for that I have to work very hard. That's not a problem. Actually I also means I always want that the student should understand all the things properly. Completion of the syllabus is the most important part, but at the same time the student should understand the things at least in a proper manner.
Yes, sir.
Yeah.
Second, scroll down.
Yeah.
Done, sir.
Done. Okay. So now we will discuss the compound microscope. And I am telling you what is compound microscope. Compound microscope have two types of lenses. One is objective lens, another is eyepiece lens. Okay. So the function
Yes,
of
sir.
both the lenses you have to understand. Nothing else you have to understand. You have to understand the function of what is the function of objective lens and what is the function of eyepiece. Okay. If you will understand that, this
Yes,
will
sir.
be very, very easy for you. So step by step we will discuss. Objective lens is smaller as compared to the eyepiece lens. So this is your objective lens, and this objective lens is smaller. And now there is one eyepiece lens, and this eyepiece lens is bigger as compared to this is the eyepiece lens. Okay. Now, what we will draw first principal axis.
Yes, sir.
This is the principal axis. Now, this is the objective lens. Objective lens. Okay. This objective lens have a small focal length. This eyepiece lens have large focal length.
Yes, sir.
Have large focal length.
Large focal length.
Large focal length. Okay. So okay. Now, I am taking one object that you want to see in the compound microscope. This is the object, and this object is placed in front of objective lens. So what will happen? Objective lens will produce the image of this object.
Yes, sir.
Okay. So we'll first draw
Yes,
the
sir.
image for this. Okay. So now we'll draw the image. So first ray is parallel to the principal axis.
Yes, sir.
And it will pass from the focus of the objective lens like this. And another ray from the object is passing from the optical center. I think I have made wrong. Just a minute, I am improving it. Actually, no, focal length of this objective is small, no? So that is why it will be something like this. Like this.
Oh, okay.
So image will form like this. Now here the image is forming, you can see. Here the image is forming by which of the lens? By which of the lens? Objective lens. Okay.
Yes, sir.
The objective lens is producing the image first of the object. This is the object that you are watching, that you are seeing in the compound microscope. And first what happens, the function of the compound microscope, first the objective lens produces the image.
Yes.
Okay, now here is the twist. Here is the twist. So this is the image. We have the image formed by the
Objective lens.
objective lens. This is the image formed by the objective lens. Okay. Suppose this object is AB. The object is A. The name of the object is AB, and this image is formed A dash at B dash. Okay. Okay, so now we can take this is the height of the object. Okay.
Okay.
Okay, height of the object I have taken. No problem. And where is the object distance? We can mark the object distance also. From here to here, this will be the object distance, no?
Yes, sir.
Object distance with respect to objective lens. And with respect to the objective lens, what is the image distance? Image distance will be this. Okay, this is the image distance, huh? V0.
Yes, sir.
Why I am writing VO? Because this is the image formed by the objective lens. That is why I am writing VO. Good.
Yes, sir.
Okay, now the game of the eyepiece will start, and this is the main game. Now for this eyepiece, this eyepiece will think this image, this is not the image. This eyepiece will think this is the object.
Okay.
And this eyepiece will produce the image of this object somewhere else.
Okay.
And that image finally you will see in the compound microscope. So now we will draw the image formation of this object. Why I am saying this is object? Because this is the object for eyepiece.
For eyepiece.
And this is the image for
the objective lens.
Objective lens. Okay. This is the first ray parallel to the principal axis. It will pass from the focus. It will pass from the focus like this. It will pass from the focus like this. Okay. Now, what we will do? Another ray from this object will be passed from the optical center.
Yes, sir.
Like this. Okay. This is the objective lens, so it will have the large focal length. It will be like this. So another ray from the objective lens will be like this. Okay. And now you can see both these rays are getting diverged, na?
Yes, sir.
Both these. Both these rays are getting diverged. These are the diverging rays.
Yes, sir.
So now after the diverging rays, what we do always? Produce the diverging rays in the backward direction.
Yes.
So now we will produce these diverging rays in the backward direction, and we will see where the image will form. See, here the image will form, and see, very large image will form this time. This much large image will form. That is the work of the compound microscope. It forms a very large image. So this will be the image, that this is A dash, A double dash, and B double dash. Okay, so this is the final image. This is
Yes, sir.
final image. So once again, I'm telling, first the object was here. This objective
Yes.
lens, with the help of this objective lens, the image of this object is produced here.
Yeah, real and inverted.
Now after that, real and inverted. After that, this image is working as an object for eyepiece lens. This
Yes, sir.
eyepiece lens is producing the image of this object here.
Yes.
So finally,
okay.
you are getting this image. Okay. So draw the diagram properly. Okay. And step by step, you have to draw the diagram, now.
Yes, sir.
For the objective lens, draw the diagram. Okay. And after that, for the eyepiece lens, draw the ray diagram. And these lines should be dotted lines. These lines should be dotted lines. Why these lines should be dotted
Because the
lines?
backward, that it's
We
not
are just
forming in
producing
real.
these rays in the
Yeah.
backward direction.
Yeah.
That is why these should be. Okay. And properly draw the diagram. And the heading is the compound microscope.
Done, sir.
Done. Okay. So now mark some more distances here. Mark this distance. This is the object for eyepiece.
Yes, sir. So UP.
UE. You can
UE.
write not UP. So we will write UE. Okay. Because we have already written UE. You can write UP also, no problem. I'm not
Like
saying
object distance for piece.
P is for just eyepiece lens.
Yeah, so it's UP maybe.
This distance will be, suppose UE. UE means no, it is fine, no?
Yeah. Yes, sir. Yeah, it's fine.
Eye lens.
Same thing.
Same thing. UE means eye lens. And where is the image for this eye lens? This will be the image.
Yes, sir.
So how we will mark the image distance? So image distance we will mark like this.
From the center to
From
the
the center
bottom.
to here.
and the value will be, this line is not looking parallel line, okay, so I will mark like this.
VE.
VE, right. Yeah, can you tell me VE we will take positive or negative?
So negative.
Very good. And UE?
Negative.
And VO?
Positive.
Very good. Now I think this concept is clear. Okay. Arrow also, na, you should add arrow also, because arrow is representing where the rays are going.
Yeah.
Okay, add these distances also, UE and VE.
Yes,
Then
sir,
we
done,
will
sir.
then we will find the magnification.
Yes, sir, done, sir. You can
Then
continue.
okay. Okay. So now, what is the magnification? Magnification of this is the if we are talking about the magnification, simply magnification of the microscope is beta by alpha.
Yes, sir.
So beta is the visual angle formed by the final image. So where is the final image? This is the final image, and
Yeah.
this final image is making some angle L beta here. This will be the angle made by the final image.
Yes, sir.
Beta. Okay. Now
Yes.
alpha is very easy. Alpha will be calculated same way like this. Okay. So there is no problem for alpha. The main problem is for beta.
Okay.
Okay. Now beta, how we will find beta? So first we will find the 10 beta from this.
Yes.
So 10 beta will be this distance divided by UE.
Yes,
10
sir.
beta will be A dash B dash divided by UE from
UE.
from the trigonometry. So first we will find the 10 beta.
Yes, sir. Opposite by adjacent.
Yeah, 10 beta will be A dash B dash
B
divided
dash
by UE.
UE.
Yeah, UE. Now, after this, if I want to find the magnification of the objective lens, so what is the formula for the magnification? Height of the image for the objective lens, height of the object for the objective lens. Okay. So
Yes, sir.
magnification of the objective lens, you will understand why I am calculating the magnification of objective lens. So height of the image means this is the image for the objective lens.
Yes, sir. Yes, sir.
So
Yes,
this
sir.
will be A dash B dash, and this A dash B dash you will take positive or negative?
Positive.
No, below
No,
the
negative.
axis.
Real and yeah.
Negative.
Sorry.
So you will write here minus of A dash B dash divided by this object is HO. AB.
Yeah, that's
HO.
positive.
Yeah, it will be HO. It will be positive. There is one formula. There is one more formula for the magnification, that is V by U. And what is V for the objective lens? V naught, that will be positive.
Yes, sir. Yes, sir.
And U naught is negative.
Yes.
Very good. Sign convention will play a very important role. Now equate both these equations. From here now, what you will get? You will get A dash B dash. So if you will get A dash B dash, this will be equal to V naught divided by U naught multiplied by H naught. Now put the value of A dash B dash here.
Okay.
So you will have 10 beta now. In terms of A dash B dash, you will put this value V naught by U naught multiplied by H naught and divided by UE.
Yes, sir.
Divided by UE. Now it's fine. Now this beta is small. This beta is a small angle, no? So
yes,
you
sir.
can write beta small. Beta small, so 10 beta can be approximately equal to beta. So instead of 10 beta, we can put beta only. So we can put beta is equal to V naught by U naught multiplied by H naught by
UE.
H naught by UE. Now, what is the alpha? Alpha is If tan alpha can be written as alpha, so from here we
Alpha.
can find alpha is equal to h naught by d.
Yes, sir.
So this is suppose equation number 2. This is suppose equation number 1. Now what is the magnification beta by alpha? Put all the values. So what is beta? Beta is this v naught by u
Yeah,
naught,
V
h
naught,
naught
U
by
naught
ue,
into H naught.
v naught by u naught multiplied by h naught by ue, and this is divided by h naught by d.
H naught by D.
H
So H naught and H naught will get
h
cancelled.
naught and h naught will be cancelled out. So this h naught and h naught will be cancelled out. So the magnification for the compound microscope will be v naught by u naught,
Yes.
v naught by u naught multiplied by d by ue. Now see, v naught by u naught is the magnification for the objective lens,
Objective lens.
and
Yeah.
d by ue is the magnification for the
For the
eyepiece
eyepiece.
lens.
Yeah.
So you can write in this, basically finally you have this formula, but you can write this formula in this way also. You can write the magnification of the compound microscope is equal to magnification of the objective lens multiplied by magnification of the eyepiece lens.
Okay.
Two formulas you should know. In examination, you will not drive again and again. You will only learn formula. If they will say drive
Yes,
the
sir.
formula for magnification, then only you will drive.